All right, seventh grade pace. Um, Coming at you with some more new material, a little bit of a takeoff of what you've been doing for the last few weeks. You guys have been working way ahead, been working with quadratics and solving quadratics. So we're just going to dig in a little bit deeper into some of the nuances of foiling and factoring and quadratics and all that cool stuff. And we're going to do something that's actually quite easy. I call them smiley face problems. They have nothing to do with smiley faces. I just put smiley faces where the answer is supposed to go, and then you're supposed to figure out what goes there. But anyway, um, the concept of today is a square of a binomial. All right, so first let's um, see what that means. A binomial, bi is 2. So it's got two different terms, like x plus 3, okay? And then it's squared. So it is the square of a binomial. Now, the first thing that everybody thinks, I'm going to turn off the light here. I see a glare on that whiteboard. Oh, that's not enough light there. I'm not restarting this video. There we go. That's better. Okay. So a square of a binomial, the first thing that everybody thinks is like, oh, that's easy. I square that guy, and I get x squared, and then I square that guy, and I get 9. I'm sorry to say it's not that easy. That's not the right answer. I can prove it by doing a simple problem, right? If I had 4 plus 3 squared, if we really were following the order of operations, I would do 4 plus 3 first, right? What's 4 plus 3? 7. What's 7 squared? 49. But if I were to do 4 squared, 16, plus 3 squared, which is 9, that's not 49, is it? So unfortunately, we don't just square each term. If these were multiplied, we would. We haven't really worked with that yet, but let me show you. You actually know what to do. You did this during our time at home. You did this like 3 or 4 weeks ago. I taught you guys something called multiplying binomials by using the FOIL method. Remember, first, outer, inner, last. Well, if you think about this, x plus 3 squared means x plus 3 times x plus 3. Okay? So now we can use our FOIL method. First of this times first of that, x times x equals x squared. The outer is the outer edges of the problem. X times 3 times positive 3 is positive 3x. The inner edge of the problem, the inside, is positive 3 times x, which is positive 3x. Interesting. These are the same. That'll come into play in a minute. And then the last of this times the last of that, the 3 times the 3, is positive 9. Okay? The middle piece is going to be able to go together. 3x's and 3x's is 6x's. And there we go. The answer is x squared plus 6x plus 9. Okay, so when you get a square of a binomial, don't square each term. Split it into two binomials and then FOIL it. But let's remember this answer. I'm gonna write it off to the side. X plus 3 squared becomes x squared plus 6x plus 9. Okay? I don't know if you guys can even see that, right? I don't know what this video looks like when you zoom in. I guess if I look closely enough at the screen. Okay, I'm going to do another one. And I won't put the I won't put the squared on it. I'm just going to go x plus 5 squared. And I'm just going to say right away that's x plus 5 times x plus 5. I'm going to go a little faster this time. First times first, x squared, outer 5x, inner 5x. I'm going to put them together, 5x and 5x, and I'm going to get 10x. See, I'm going a little faster this time. Last times last, 25. Interesting. Okay. So when it's x plus 5 squared, x plus 5 squared is x squared plus 10x plus 25. Okay, maybe one more. Well, let's do x plus 8 squared. I'm going to keep these small, too. I'm not going to do the big numbers yet. We'll do it later. Okay, x plus 8 squared. I'm just going to jump to the x plus 8 times x plus 8. Okay. And again, I'm going to go fast. First comes first. This is a pretty easy pattern here, right? X squared. Outer, positive 8x. I'm going to stick with positives today and this week just so we learn the process. Inner times inner. Maybe there'll be like one negative on one of the problems. Okay, but inner times inner, also positive 8x. So what's that going to come out to? That's going to come out to 8x and 8x is 16x. And then again, my last times my last is positive 64. I'll write that one over here. Okay. X plus 8 squared is x squared plus 16x plus 64. Okay? Now, here's what you got to do. I'm asking these questions in a weird way. Let's first see if we can find a pattern. Okay? Here, let's look at this one. Okay? X plus 3 squared. What's the last number? 3 squared. X plus 5 squared. What's the last number? 5. The square is 25. Here, 8, 8. 8 times 8 is 64. Okay? So the last part is easy. So if I said x plus a squared, my last part is going to be 8 squared, 3 squared, 5 squared. My last part is going to be a squared. Okay? My first part on all of them is the first thing squared, x squared, x squared, x squared. My first part is going to be x squared. Here's the tricky part. The middle piece right here, 6x, 10x, 16x. Can you see the pattern? How does 6 relate to 3? How does 6 relate to 3? It's double. Okay? How does 10 relate to 5? It's double. How does 16 relate to x? Did I say x? How does 16 relate to 8? It's double, right? And don't forget, we also have the x. Okay? So x plus a squared, x squared plus double a plus 2ax. Okay? We double that number. We double the 8, we get 16. We double the a, we get 2a. We double the 3, we get 6. We double the 5, we get 10. Okay? Cool? All right. That's a square of a binomial. Now we're going to work backwards. Remember, we FOILed, then we factored. Okay? Well, that's easy. Try to go fast. All right. Okay. I'm going to go x squared plus 14x plus 49. Oh, remember the middle was doubled? The middle was doubled. Was the double? Remember x plus 8 squared? The middle was 16x. Okay. So now the middle is 14x. So what number has been doubled? 7. Okay. This is x. And that's it. We're done. Now this only works if this is this guy squared, this is this guy squared, and this middle piece is double this. And if you really think about it, it's double this times this, right? It's like the product of these two, 7 times x, 7x, double it, 14x. So there we go. We work backwards. Let's do one more working backwards. Okay, let's go with x squared plus 20x plus 100. Okay, that's x. That's 10. Half of that, right? This guy doubled is that. And there we go. It's just that quick. Okay, all right. Now the last piece is the smiley face problems. And you'll see. Let me just do one. Okay. If I said x squared plus 12x plus smiley face. And I'm like, man, I'm really digging these squares of binomials. They are so much fun. Okay. I keep noticing that this number that's in the middle is double the number that's on the outside if you times it by like that guy in the beginning. Okay. So my question is, what has to go where the smiley face is to create one of these special squares of binomials? What do we wish? Well, remember, 16 is double 8. 12 is double what? Okay. So what would the smiley face have to be? The smiley face is the last thing on the end. 6 squared is 36. Okay? Let's do another one. And what I'm asking you is, it's kind of a weird way to ask a question, but the questions that I'm going to be asking on your sheet are, what would go in the place of the smiley face in order to make one of these special squares of binomials? And the answer is, you're just going to take half of this number. That's it. And then you're going to get that number 6, and you're going to square it. All right. So let's get some memory items in here. Let's go with 32. Okay. So what's half of 32? 16. So what do I wish was out here on the smiley face? 16 squared. This time I'm going to actually erase it, right? And the smiley face would be 16 squared, which is 256. Okay? The smiley face, the spot would be taken up by 256. Okay, last one, and then I'll leave you to it. Okay, let's change that. Let's change that. Let's make this, let's do some more memory items. Let's do 34. Okay, this time I'll leave a blank where the smiley face goes, right? Smiley face. Okay, what's half of 34? 17. Okay, and then my last times my last, right? If I did x plus 17 times x plus 17, my last times my last would be 17 times 17. You guys better know this. 289. Okay? So that's it. There's going to be a little bit of a con stuff on the squares of binomials, just recognizing what they are. And then there's going to be like my sheet which is going to be figuring out what would go at the end in order to create one of these special squares of binomials. All right, have a great day. You don't even have to solve this time.